All right, so here we are practicing what we just did a lesson on, understanding parent functions and transformations. So given each function, identify the parent and transform and so on, and write down what the transformations are. So let's start. This is an absolute value. There it is. That's the parent. What's happening on the outside? So 2/3 actually means it's less than 1, so it's a vertical compression by 2/3. And then inside, what direction is it going? So it's horizontal, and it's going to the right, 4. Identify the parent, x cubed. What's happening? On the outside, I see a vertical shift up. It does what it says, 7. On the inside, I see a negative, so that means it's a reflection. And on the inside, what does it reflect across? Or about? And it's the y-axis on the inside, x-axis on the outside. Number 3, what's the parent? Just the rational or reciprocal. What's happening on the outside? So there's a vertical shift down 1. What's happening on the inside? Well, I also see the 6. Now, technically, that 6 that you see is multiplying. So you could think of that 6 as being multiplied in front, take away 1. So when it's in the numerator of a fraction, it affects the y. It's the denominator that affects the x. So anyways, a long way of saying this is a vertical stretch by 6. 4. What is the parent? I'll just write it here. It's square root of x. What's happening on the outside? That's a vertical shift up 7. How about on the inside? 2 things. The 4, we call that a horizontal compression. In the inverse, that's 1/4. And then inside, it's a horizontal shift in the opposite direction. What direction are we going? Right 2. 5. The name of it, it's the greatest integer function. What's happening on the outside? I see a vertical shift up 5. I also see that on the inside, we call it a stretch because it's the inverse of it. So it's not 1/2, it's 2. 6, that's a square root function. What's happening to it? Well, that negative on the outside, this just takes practice. It means it reflects about the x-axis. What is the dividing by 2 does? Well, that means it's a vertical compression. And the actual number is 1/2. 7. What do we see? Parent, just x squared. What's on the outside? I see a negative. That means it reflects about. So remember, on the outside, it's the x-axis. What else do I see? 5 divided by 2. That makes it a vertical stretch. That's 2.5. So a fraction doesn't mean it's a compression. It has to be a fraction between 0 and 1. And then what else do I see? Inside. So that means there's a horizontal shift. What direction? Left. How many? 11. 8. What do I see on the outside? Oh, so the parent, there is the reciprocal. I see 9. What does it do? It goes up. How many? What do I see on the inside? So it's a horizontal shift, opposite direction. Right, 5. Just takes practice seeing it. 9. What is the parent absolute value? What's happening? Well, on the outside, it's a vertical stretch. On the inside, the negative does a reflection. Well, which axis? So on the inside, it reflects about the y-axis. How about this part on the inside? What does it do? Well, it shifts what direction? Right. How many? 3. 10. What's the parent? Cube root of x. What's happening on the outside? Well, I just see the subtract 4. So what does that mean? So vertical shift down 4. How about on the inside? I see a negative, so it means it reflects. About what axis on the inside? That's the y. What else do you see? Times 5. But the inverse of that's 1/5, so it's actually a horizontal compression by 1/5. And the last thing I see is inside, adding or subtracting is the opposite direction. So it's horizontal on the inside. In what direction? Left. How many? 9 from the parent. All right, turn the page. What's the parent? Can you translate this parent? So it's definitely parabola x squared. How would you translate it if it went 4 units down and 3 units left? Well, inside is left, and we changed the sign, so that means left, 3. And then 4 units down means you subtract 4 on the outside. How about if you take that function and you do a vertical stretch by 2, so that would be on the outside. Then translate it 5 units left, so that would be on the inside, and again you change the sign. So, and then double check, go back and make sure, yeah, that's times 2, add 5, the inverse, and it fits. This, what's the parent? That's the square root of x. How about if you translated it 3 units up and 8 units right? So if I go 8 units right, that's subtracting. If I go 3 up outside the square root, I'm going up 3. How about if I take that same one and I horizontally compress by a factor of 1/4? Then reflect in the y-axis. Well, the y-axis is inside, so inside will be at negative. 1/4, we then do the reciprocal, we do the inverse, so that's 4. And you have it. 13, what do we call it? Absolute value. How do you stretch it horizontally and then translate it 4 units down? So inside, we're going to go 1/3 x, do the inverse, and then subtract 4 on the outside for going 4 down. How about if you stretch it by a factor of 3/2 vertically, and then reflect in the x-axis and translate? Remember, the y was on the inside, the x-axis is on the outside with the 3/2. And then if it's going 3 units to the left, we add. Add 8. 8 units to the left, we add 8. 14. Parent, what is it? X cubed. Okay, vertically compressed by a factor of 1/2. Then y-axis, I'm assuming reflecting. Then reflect on the y-axis. I think it wants to reflect, it's not word in here, on the y, and then translate 4 units to the right. So one step at a time. So what's happening on the outside? So vertically is on the outside by 1/2. It does what it says. The y, if it reflects on the y, that means it's inside. And then what else is happening? Well, it's going 4 units to the right. So I need another parentheses and subtract. And you have it. One more time. What's happening? Reflect on the x-axis. That's outside. Translate 7 units up. That's on the outside. So on the inside, we need parentheses, not on the outside. Here comes some Yoda Jedi mind stuff to go backwards here. If you have this function and you do a horizontal stretch by a factor of 2, so I'm already thinking of 1/2. Reflect it across the x-axis. I'm thinking, is that inside or outside? That's outside. Translate up 3. That's on the outside. Write the equation of the new function. So I'm going to call it f1 at x. So if you do a horizontal stretch by 2, it really means divided by. So on the inside, instead of 4, what's 4 divided by 2? That gives me the 2. The x-axis means it's going to happen on the outside. And if it's translated up 3 and so on. So there's going to be a negative on the outside. And then if you go up 3 and it started at 1, well, now we're at 4. All right, now we're going the other way. This is the true Jedi way, going backwards. So this was the end result. What was it at the beginning? So whatever it was at the beginning, you stretched it by 3, then translated it down, and then 7 units to the left. What's happening here? So we're going to go backwards. So instead of times 3, we're going to divide. So let me just do that right here. Negative 3 over 2. We're going to divide it. Now when you divide it by 3, it means the same as 1/3. So what's the number in front? So we have negative 1/2. Let me write a function here. So that means if I go negative 1/2 times 3, it should equal what it was before. Good. Then I'm going to go 7 units to the left. So I have to add 7. So that means inside. So 7 units to the left. But that's what it became. So I'm actually going to do what it says. I'm going to subtract. So in other words, make sure I'm doing this right. If I start with negative 3 and 7 units left means you are actually going to add 7. So negative 3 plus 7, does it give me what I need? Yes. And then 5 units down, and it gives me the answer negative 2. So it must have started at something that was above negative 2, right? So if I have 3 and I go down 5, that's what would give me negative 2. All right, good job practicing, thinking, working, struggling, all that good stuff to figure out parent functions and transformations.